Alright, let's learn how to play the game. Because 2.2 is verifying trigonometric identities. Dude, you only have a couple problems assigned on your WebAssign, but you've got a couple quizzes or worksheets, or whatever the hell you want to call them, to complete. And this is how we play the game. It's just one game. It's the only game we play in 2.2. It's called Establish the Identity. That's it. That's the only instructions you need in 2.2. Establish the identity. And let's start with this. This is true. Cosine of theta times tangent of theta equals sine of theta. How do we play the game? You get two choices. You can mess with the left side, you can mess with the right side. But you can only touch one side of the equation. Well, sometimes you mess with two. It's basically no algebra. No algebra. Like, I can't do this. Like, this was not allowed. I couldn't just divide out cosine and do this. That shit's not allowed. No algebra. You mess with one side or you mess with the other. You typically mess with the side that has the most complicated crap in it. All right? One of them's got two terms. Well, we didn't really. I misspoke that. Cosine of theta times tangent of theta. That's two thingies. That's more complex than the one thingy. So let's mess with the left-hand side. And again, no algebra. No algebra. It doesn't have to be the left-hand side. So I'm just going to change tangent. Just going to change tangent. And tangent is sine over cosine. Well, look. That goes away. So this is equal to, what's left over? Sine. Okay, we're done. There's no answer to these problems. We already know the answer. That should equal sine. That's not the point. The point is showing that one side is equal to the other without using algebra like multiplying both sides of the equation by something. You do that, you get 0 points. You can't multiply both sides of the equation. You can't divide things on the equation. You just mess with one side or the other to get to your solution. Let's see another one. Again, there's no answer. So here we have secant squared of x minus 1 over secant squared of x is equal to sine squared of x. That's just truth. There's no answer. We're going to show that one side is equal to the other. So we look at what's more complex. And I believe the left-hand side to be much more complex. Now, while we do these, there's not a right way through it. I've stolen this one from your textbook. I wouldn't have solved it that way. So I'm going to solve this in two different, I don't know why I'm saying solving. I'm going to establish the identity in two different ways. And again, there's no answer. Don't circle anything. I just throw a little check mark at the end. If you took it in high school, they probably taught you LHS or RHS, left-hand side, right-hand side. I always see that from high school students, or people that learn trig in high school. Must be something to do with some standardized testing or something. So, all right, here's the first method for going through this that I see. Since this is the more complicated side, let's mess with that. Now, right off the bat, you see a secant squared. You start thinking identities. Identities. You see something squared, you want to think identities. So we have the tangent squared of x plus 1 is equal to secant squared. But we need to know all different other ways of doing it, all right? So if you were to subtract the 1 over, you're going to find out that tangent squared of x is equal to secant squared of x minus 1. We're using a Pythagorean identity there to say we can actually change our secant squared of x minus 1, and we can just turn that into tangent squared. So let's do that. We'll change it into tangent squared of x. I think at this point, something smart to do, huh? There is only sine and cosine. So let's keep rolling on down. All right, cool. So let's start on the bottom. Secant squared. Isn't that 1 over cosine squared? That's secant squared. Now let's go up top. And tangent squared is sine squared over cosine squared. Now I'll show this step, but we should be pretty good about doing this. If both those denominators match, it's just going to cancel out. I'll show why. So at this step, you could just be like, bang, sine squared. But I'm gonna go a step further. Let's say sine squared of x over cosine squared of x. So that's the numerator right up here, the numerator. Now we're going to take this and we're going to divide by 1 over cosine squared. I keep saying I'm going to stop doing this and showing you, but I really want you to know this. Just learn the flip up trick. Hiya, 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 and that equals sine squared of x. See, that's too much. I mean, I think just going like this and going what's left over, sine squared of x, and being done right there is much better than having to do all that work. So feel free to do it. And look, there's no answer. It's just once we get down, once the left-hand side is the same exact frickin' thing as the right-hand side, you're done. You don't need to write anything. You don't need to circle anything. You don't even need to put a frickin' check mark next to it. When I grade these, I'm not looking at the answer because there is no answer. I'm looking at your work. I can tell when you're doing nonsense. Every semester I teach this class, somebody tries to just put fake bullshit down. You waste my time, I'll make it worth your while. You waste my time, so don't write nonsense. I see it a lot where students will just write garbage and then just put at the end sine squared. I won't fall for that, I promise you. So don't do that. All right, let's do one more. I'll stop threatening you. Jeez, I should calm down or something. One of those, I don't like my time wasted. But it's all good. It's all good. I probably would have done the same thing as a student. So this one, complex. This is going to be a little bit more. So get ready for it. Now, like this is a good test level problem. The first two, I don't know, they're a little too straightforward. A little too straightforward. I want to see you do some algebra. I want you to add some fractions. I want you to show me some stuff. So this is starting to get to it. And so out of 10, I'd say this is, I don't know, a 5, maybe a 6, maybe a 5. Let's go 5. Let's not get crazy. So I think right off the bat, since tangents and cotangents don't have shit to do with each other except for the fact they're co-functions, but as far as the Pythagorean identities, right, sines and cosines go together. Secants and tangents go together. Cosecants and cotangents go together. So I'm thinking, you know what? Let's go to the old standby. Let's just go get this shit done. Let's just go sine and cosine. It'll be like 1 plus, and let's change tangent of x into sine of x over cosine of x. And now we're going to change cotangent. Well, shoot, that's just going to be cosine of x over sine of x. We chill? We're chill. Well, I don't know about you, but I don't like complex fractions. We got 2 options. I mean, I didn't solve that one. The one before in another way. Oh well. I said I was going to. I didn't. I'm not turning back. So we have options. We can call this cosine over cosine and add it together. We could call this sine over sine and add it together. Or we could just multiply by the least common denominator. Sine times cosine. And we can clean everything up real simply. Sine of x, cosine of x over sine of x, cosine of x. I'm just multiplying by 1 because that's really the only thing we're allowed to do. We're allowed to manipulate, use formulas, factor. We can add fractions. We can also multiply by 1 because you're not changing anything. So what's going to happen is there's an implied parenthesis here. So it goes whoosh, whoosh. All 4 pieces. So let's write it out the long way. Hopefully you never have to write it out the way I'm about to. So there's that sine of x, cosine of x. That gets multiplied by the 1. Next, we move to here, and we're going to have that cosine of x down on the bottom. And we got that sine of x is still up top. But now we need to bring in that sine x, cosine x. Keep going. All right. And now we go down to the bottom. So we're going to bring this in. We multiply by 1. So you get sine of x, cosine of x. Plus, and then we write in our sine of x here and our cosine of x up here. And once you see it a couple times, like, pay attention to the freaking patterns. So you don't have to write all this, where you can be like, oh, bruh, sine x, cosine x, and then when I bring it over here, the cosines just go away. This is sine x, cosine x. When I bring it over to here, the sines just go away. Or if you need the training wheels, frick it. Do it. Do it. Because this is what I'm talking about. Look at those cosines. Whack, gone. Look at the sines. Gone. Beautiful. Now let's just rewrite this thing. What do we got? Sine x, cosine x. Plus, what does this turn into? Sine times sine, that's sine squared. Down below, what do we got? Sine, cosine again. What do we got? Plus cosine squared of x. Let's factor. Huh? We could have added those fractions. Things could have looked different. This is actually the first time I've ever done this method on this problem. I've done this one 100 times. So I see a sine and a sine. I see a cosine and a cosine. So let's factor. Let's rip that sine out to the front. And that's going to leave us with cosine of x plus sine of x. Now let's take out those cosine. You get cosine of x, and what's left in there? Sine of x plus cosine of x. Oh shit. You know cosine plus sine is the same thing as sine plus cosine? These are the same thing, so they go gone. And what are we left with? Sine of x over cosine of x. And what is sine of x over cosine of x equal? Tangent of x. Was that what we were supposed to get? Oh shit, it was what we were supposed to get. We were supposed to get tangent. Oh, wow. All right, we did it. Okay, I'm actually going to go back up to number 2 if you're interested. Another way to solve this problem, secant squared of x minus 1 over secant squared of x. I would solve it by doing this. If you have a single term in the denominator, you could put it down below of both. Secant squared over secant squared is 1. 1 over secant squared is equal to cosine squared. Do you know what 1 minus cosine squared equals? Sine squared. I like that method best. So that was the other way for number 2. I'll see you in the next one.